Greetings everyone, this is Mr. Mull, and I'm just going to show you this first problem on this ideal gas law worksheet. As you're working through these, how to look at it a little bit differently than some of the other ones. The key about the ideal gas law is that when we're looking at a set of conditions that are not changing, and so we're looking at 3 or 4 gas variables and trying to figure out something else about a specific sample of gas. And so I'm going to go ahead and look at this problem. It says, what will the pressure be? And so we're looking for pressure by a 0.45 moles of gas. And so now what we're going to do, I'm going to go ahead and put my P. Now I can put P1 here if I want. I mean, I don't know yet if the pressure is changing or not, so I'm just going to put a P1. There may not be a second pressure. It may just be a one set of conditions. It will be exerted by 0.45 moles. So I look at moles, and I know this is talking about how many particles I have. So this is now N. It's equal to 0.450 moles at 25 degrees C. And so this is a temperature, and my temperature is 25 degrees Celsius, but I'm going to add 273 to that in order to take us to Kelvin, which is 298. Okay. Is contained in a vessel whose volume is 650 milliliters. So I have a volume 650 ml. Okay, so I see P, I see V, I see N, I see T, and I notice that the conditions are not changing. So we're really looking at one gas sample, and we're trying to figure out some unknown. And so we're going to solve for the pressure that this gas sample exerts. To do so, I'm going to get an equation that relates P, V, N, and T. That's going to be PV-NRT. PV equals nRT. And so I'm going to go ahead and rearrange this to solve for P. To do so, I'm going to divide both sides by V. That means my pressure is equal to nRT over my volume. And so now I can go ahead and plug in what I know. My pressure is equal to, when I plug stuff in, N is going to be 0.450 moles. When I use R, I'm going to use the gas constant R, and I'm going to look at the pressure that I have, and it doesn't actually specify. So I can use any of those 3 gas constants we talked about. I'm going to use ATM just because I'm comfortable in atmospheres as an easy one. So I'm going to go ahead and use 0.08206, and then the units on this gas law, or this gas constant, are liters times ATM over moles times K. I'm putting on my units because we're going to see what happens to those in a second. And that's all nR. Now we need temperature times my temperature, which was 298 K. And we divide that all by the volume. Now here's the problem. Looking at my units so far, moles cancel. K, as in the numerator here, cancels with this K. So now I have liters on top and ATM on top. Now I want my pressure in ATM, but I need to get rid of liters. When I look back at the volume they give me, it's in milliliters. And the unit-wise, that's not going to work out, and it's going to give you the wrong answer too. So what we have to do is we have to convert that to liters. So I'm going to use my conversion. For every 1 milliliter, there are 1 milliliters. Okay, basically I just need to divide by 1,000 to get us to liters. And so that's going to take me to 0.650 liters. And now I can plug in my unit. 0.650 liters. Liters now cancels from the top and the bottom, leaving with ATM as my final answer. When I plug all this in, my pressure is equal to 16.9 atmospheres. And there's my final answer for pressure. Now, you can use this same gas constant here. If you're given other units such as kPa or torr or millimeters mercury, whatever, you can use a different gas constant. This is just the one that related the unit of pressure for ATM, and that was fine for me. It didn't specify what kind of pressure it wanted. And the other thing is, no matter what you do, look at the units of the gas constant that you're using and make sure that you have those exact same units in all the other problems. On the quiz, you may be given a pressure in, let's say, kPa, and you have to convert it to millimeters mercury or something in order for that correct gas constant to work out that you're using. So just keep that in mind, and that's all. I hope that this was helpful. Have a great day.